slope-intercept form, and then our point-slope form. Okay. All right. So in number one, let's see if we remember of this. It says given a line with a slope of 1/2, and then you're going to go through the point 4, 3, write an equation of the line in point-slope form and in slope-intercept form. So again, we'll go ahead and say, all right, let's say slope-intercept form we'll do on the left side. And then the point-slope version we will do over here. The thing to keep in mind, while we're more familiar with slope-intercept form, the only way we can do slope-intercept form right away is if you know the slope, which we do, but also if you know the y-intercept, which we don't. I'm not giving you the y-intercept. This point is not when we cross the y-axis. So while you're probably more used to slope-intercept form, we can only do that if we know those two pieces of information. Point-slope form means we need a point, any point, and a slope. Those are the two things that we're given. So this is really the one that we would want to start with. All right, so again, we were pretty good with this on Monday, and then if you were here on Tuesday when we did that little turkey, everybody was pretty efficient with these. The m is your 1/2 slope, so you're putting that 1/2 right there. And then we would do x minus, this just references the x coordinate of the point that you were given to work with. That x coordinate is a 4, so you would do x minus a 4. And then we would do plus y, and then the y one here is just the y coordinate of the point that you were given to work with, which is that 3. And then this is your answer for point-slope form. You can just leave that. All right. To get slope-intercept form, then all we did is we then took this version and we simplified it. So I'm just going to rewrite this over here, what we just came up with. And then all we did is simplify the left-hand side. So that would require us to distribute. So the 1/2 times x gives you a 1/2 x. And then that 1/2 times the 4 is basically saying 1/2 of 4, which is 2. And then you still have the little plus 3 right there. So then final answer in slope-intercept form, just add up those like terms, positive 1, and then that's how we can convert that into slope-intercept form. Okay? And again, that's what we were doing for the most part, Mondays and Tuesday classes. All right. All right, number 2. This one says, write the equation of a line in, again, point-slope and slope-intercept form. So I'll put slope-intercept form here. And then point-slope form there. All right, now this is one that I can do slope-intercept first. This is what you've probably done the most of over the last handful of years, because I can look at this line, and when I now ask what is the y-intercept, we can actually look at the line, and we know our y-intercept is the 3. So because of that, we can do slope-intercept form right away. All we need is our slope. So go ahead and get the slope of that line. And then we know our y-intercept is going to be that plus 3. All right, get the slope. See if you remember how to get that. Pens don't want to be here either right now. They're waking up. All right, slope. So hopefully we got that right. Pick good point. So this is a nice point. This is a nice point. There's another one down here where it's going through those corners perfectly that we can use to count off. And then you can either go up 1, 2, 3, left 2, up 1, 2, 3, and left 2. That would be a positive 3 over negative 2. Or you can go down 3, right 2, down 3, right 2. Either way, you should get a slope of negative 3/2. All right. Whether you go down 3, right 2, or up 3, left 2. All right. So that's our slope-intercept form. That one we can do first because we knew the y-intercept. The point-slope form now. Here's our point-slope form. So we need to look like this. Any point works. So we now have 3 points to pick. So if you pick this point here, you're going to use the point with the coordinates 0, 3. If you use this point right here, those have coordinates of 2, 0. Or if you want to use this point, this is the other nice point, you would use the coordinates for -3. Does not matter which of those 3 points you use to write this point slope version. All right. So Maddie, what point do you want to use, Maddie? Okay, so if we're going to use this point right here, the 0, 3 point, then I'm going to come on over here. The slope is going to be the same as it was in the other version, -3/2. And then I'm going to do x minus the x coordinate. Since Maddie picked this point, that x coordinate is going to be a 0. And then plus our y coordinate. The y coordinate in Maddie's point is a 3. So that would be our answer. And again, if you pick this point, that's fine. If you pick this point, that's fine. This version will look a little bit different. But if you remember, if we clean this up, they would all give us the same slope-intercept form. Okay? All right, so that's how we did it with a graph. All right, this is somewhat new this year anyway. We didn't do one of these just yet. If I ask you to write the equation of the line that passes through 2, 5, 2, -3, a couple things. I don't tell you specifically which type of a line, slope-intercept form or point-slope form. So what you would have to kind of understand, neither one of these points is your y-intercept. So because of that, we would in all likelihood want to go with point-slope first. And then we can use either of those 2 points. Our issue, though, and every one we did on Monday and Tuesday of last week and so far today, you were always given a way to find your slope. I either gave it to you, or in the problem that we just did here, we did it by counting off the slope of that line. Here, I don't give you the slope. So then we have to recall how we found the slope of 2 points. So hopefully, remember the slope formula from back in the day? That thing is something you want to now know, because we will use this often. This is that whole little, it really is just your change in y's, just like we wrote on the graph, over your changes in x. So this means y sub 2 minus y sub 1 is the change in x. x2 minus x1 is your change in the x's. All right, all this means is here's point number 1. I'll call this point number 2. Y sub 2 means you're going to go to the second point and you're going to find the y coordinate in that second point, and that's going to be your -3. So we're going to slot the -3 in there. Then you're going to do your minus sign. Y sub 1 means you're going to go to the first point and grab the y coordinate from the first point. So that's going to be 5. So that's our numerator, -3 minus 5. Denominator, this is the second point, and I want the x coordinate in the second point, so that's going to be a 2. Oh, this one's sneaky. This is maybe a little sneakier than I want it to be right now. So make that a 2. Let me change this. I don't know why we would do this to you right now. Make this to a -2. Make that to a -2. Let's not go crazy. All right, and then we're going to do minus. And then I want the x coordinate of the first point, which is now a -2. Whatever that simplifies to be, that's going to be your slope. All right, so in the numerator, I'll get a -8. In the denominator, notice how we have these little double signs. That happened often when you did the slope formula. So you're going to end up adding those. So that's going to be a 4. And then that should be a -2. All right, so we come on over here. I now know my slope is a -2. You can, again, pick either one of those points. So it does not matter which point you pick. So Joe M., which point do you want to pick, Joe? Just pick one of them. All right, so if we pick point 1 now, we can write the equation of this line. So in x sub 1, I'm going to erase x sub 1, and the x coordinate of the point that Joe is picking is a -2. So we end up with x minus a -2. And then y sub 1, -3. Or I'm sorry, is that +5? So then we do a +5. All right. We got it. And then end up with our double negative, and then we're going to add that. Okay. Okay, number 4 is the one that we're going to see a lot and what we're going to be doing here shortly. go ahead and do that one. No typos in this one. I want you to do this one. And then when it says describe the line, see if you remember this. This is what we're going to do a lot of here shortly, and then for the next few sections. So go ahead, try to write the equation of that line. And again, since you're not given the y-intercept, this is probably the version we want to go with. All right, what are we coming up with for this slope here? Julia? Good. You should be getting a 0 slope. Okay, nothing wrong with that. Certainly is going to happen. We'll see here in a minute when we start what we're going to be doing. We're going to get a lot of them with a 0 slope. The reason for that, when you subtract your y's, so this is just saying subtract the two y coordinates. Well, they're both 5s. So the numerator should have been a 5 minus a 5. And then your denominator, you're going to subtract your x's. So you would have a negative 4 minus a 2. So numerically, you get a 0 on top. You get a negative 6 in your denominator. And then that would obviously give you a slope of 0. So let's go over here. And let's go ahead. Let me not erase it. Let me go and put this in. I'm going to put a slope of 0 right there. And then I'm going to do x minus, I'll pick the first point again. So we'll pick the point 2 comma 5. The x coordinate of that point is the 2. And then the y coordinate of that point is a 5. But let's clean this up real quick to see how this plays out. If I distribute this 0 right here, isn't 0 times anything a 0? Yeah, so this all pretty much just cancels out. And all you are going to be left with is that 5. So here's what you want to get down. Here's what we're going to do quite often now here over the next few days. What kind of a line, a couple things here, has a slope of 0? Anybody remember that? All right, Monica, what do you got? Good. This is a horizontal line. Okay, any line that is horizontal will always 100% of time have a slope of 0. Think about what a horizontal line is. Here's what I was going to graph real quick. If nobody had thrown that, we'll go ahead and do it so you understand what I mean by horizontal line. If I plot the point 2, 5, that would be this point right here. And then if I plot the point negative 4, 5, so negative 4, 5, and I now connect those two dots, notice how this is what Monica said it is. That is a horizontal line. So the two things we want to know about a horizontal line, whenever I have a horizontal line, your slope is always 0. And then if you look at this equation here, notice how there is no x. It's always just y set equal to some number. The equation of a horizontal line is always y equals some number. All right, there will be no x in there. Okay, so keep that one in mind. We're going to see that quite often. Okay, all right, go to the next page. Move this up one spot here. All right, and it says create a story. We're going to kind of go through this together so we kind of all have the same story so we can kind of do this. But you're going to look at this graph. We're going to make up a story based upon what this graph looks like. And then when we do this, so when eventually I probably will have you do this, you're going to label your x and y axis. We want to be as specific as possible in describing what is happening in our story here. All right, so let me make this a little smaller so everybody can see this. All right, and the way we are going to label this, so if you look at your y-axis right here, we're going to label this blocks from home. Like city blocks. Okay, a block away from your home, you're 1 block away from your house. All right, and then our bottom, our x-axis is going to get measured in minutes. So if we understand kind of the premise of this, at the very beginning, we're at home. So before we leave, before we do anything, we are no blocks from home because you are at home. And then if I go 1 minute later, notice how I'm at the point 1, 1. So after 1 minute, that means I walked 1 block. After 2 minutes, I walked 2 blocks, so on and so forth. All right, kind of understand that. All right, so what we're going to start this out as, our first thing is, number one, in terms of creating our story, is that we'll use I since we're all writing our own. All right, I leave for school. All right, and you're going to walk. So pretend like, so we're leaving for school. We're heading to school in the morning. So we'll say we leave for school in the morning. All right, so we're 1 block away, 2 blocks away, 3 blocks away, 4 blocks away. Notice what happens after 5 minutes. At 5 minutes, I am 5 blocks away from school. After 6 minutes, aren't I still 5 blocks away from school? I'm still 5 blocks away at 7, 8, 9. So this 5 minutes, what's happening here? Like what's going, yeah, Julia, you're stopped. All right, so if I gave you at some point, if I had you create your own little story that I'm going to read, we want to indicate why would I have stopped for 5 minutes, whether that be you stopped at Starbucks to grab a coffee, if you stopped at a friend's house to talk with them, or whatever. But there's 5 minutes where you remain 5 blocks from school. Okay, so we want to kind of understand what that means. So you can kind of put whatever you want. I'm going to put that I stopped and picked up a friend at her house or his house, whatever friend you might have. And then I'm going to put, but she was not ready. Or he. And you waited 5 minutes for her. All right. All right, so that now takes care of these 5 minutes. Well, after that, then we head off to school again. So now she's ready. We're going to get further away from her house or his house. We're also getting further away from my house. So then it said at 10 minutes, my friend and I leave her or his house. All right. All right, so then again, all this time now, we're getting further and further away from her house, your friend's house, and your house. But eventually we get to this point right here. And then again, our whole destination is this should be school at the very end. If this is our ultimate goal, we're trying to get to school. So over this 15 minutes, what I would kind of say is we went to go pick up another friend on the way. This person was just ready. All right, so we walked to their house. So I'm going to say at 10 minutes, my friend and I leave her house. At 15 minutes, we pick up another friend. All right, so that would get us to right here. And then 5. All 3 of us walk to school. All right, so then at that point, we stop. No worried about timing it anymore. We've arrived at our destination, so there's no need to time anything. A lot of different questions. I can ask, how long did it take you? Well, it took you 20 minutes. You know, there's a lot of different questions that go into it that we're going to ask you some of those here. But we want to be able to kind of understand how to read this graph, okay? All right. Number 2, we're not going to go into that too much, but just saying if you were to write a function to match each part of the story, well, yeah, actually, we do want to write, sorry. how many would we write? So what that is alluding to, there are 4, if we look at this here, notice how this is a line. If I ask you to write the equation of that line, wouldn't the equation of that line be different than the equation of this line? Those would all be different than the equation of this third line. And then I have a fourth line right here that would have a different equation than the previous 3. So when this says, if you were to write a function to match each part of the story or section of the graph, how many would you write? If you look at that, we would need 4 different parts. All right, we would need 4 different functions. All right, so then from there, that's ultimately what I want you to be able to do. So it says identify and write the function. Let's do that first. Don't worry about your domain yet. So do the first line. So now this is our third day. So this blue one here, that starts for the 0 minute and we end up at 5 minutes. Write the equation of that line. Okay, so what we did Monday, what we did Tuesday, what we reviewed on the first page. Write the equation of just this first blue line and put it right here. All right. When we look at this one here, so I blew it up. We're just doing this blue one. Let me even get rid of all of this. So just this blue one right here. It's really up to you. You have a couple of tools now that you can use. You have slope intercept form and you have point slope form. Do we know the y-intercept for the blue line right now? Do we know where the blue line crosses the y-axis? Armando, do we? Yeah, where does this blue line hit the y-axis at?
0, 0.
Yeah, wouldn't it hit 0? So putting this in the slope intercept form is definitely an option in this case because we know our y-intercept is going to be a 0. You don't have to, and we'll show point slope form here in a minute. But I think if you know the y-intercept, that typically is kind of what everybody likes and what you have done for a while. Then all we need is our slope. So at this point, I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. So the slope of that line is a 1. Now, we can do point slope for sure. Our slope would have been a 1, just like it is before. And then you pick any point. You could pick 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. You could pick any of those, but we could do point slope. But I would think in this case, slope intercept form is probably your best bet. So the equation of that line, we're going to simplify to just be y equals x because we don't need that 0 at the end. So what you're going to put, since this is the equation of that first line, notice how this underneath says the subfunction. There are 4 subfunctions that make up that overall graph. The first one is simply y equals x. But notice here, this is your y. So this is really y equals, all I really need to put right here is the x. And again, it's this big brace means this y is going to equal all 4 of these, but the first one is just y equals x. Our domain, what that alludes to is the time interval in which that function was defined. So if I go back up to this, we would all agree that this blue line starts at 0 and finishes up over here after 5 minutes. So we want to write our domain between 0 and 5. So there's a couple different ways to do it. If you do the interval notation, that is okay. That's probably the easier one. 0 to 5, that's 5 minutes. That's our domain. What you're typically going to see this written as, though, so this is how we're going to write it. You're typically going to see this in what's called set builder notation. That's just the inequalities, where we want to stay less than or equal to 5. So we want to say under 5 minutes. But we want to be on the greater than or equal to side of 0. So again, I'd probably take either, but typically you're going to see these intervals written with the inequality notation. All right. So that's our first one. Y equals X over the interval of 0 to 5 minutes. The first 5 minutes, basically. All right, so real quick, go to the domain of the second one. So before we actually write the function, look at this second function, because now you're going to do the yellow one, the one that starts at 5. Write the domain real quick. And again, the domain is simply the time interval for that second sub function. All right, and see if you understand how you're going to write that. All right, and Ella, how'd you write it? For the second one? All right, so what the second one is saying, where does this yellow one start at? What time? 2 minutes, 3 minutes, 4 minutes, or 5 minutes? Okay, so that's where we want to start this guy. So start with the 5 now. Then what you said is good. So you're going to do less than or equal to your X. Because this, well, actually, we're going to change that here in a second. But where does this one end at? Time-wise, 10 minutes, right. So then we're going to say less than or equal to 10. So did we travel that yellow line? Again, domain of your X value. So we're writing the interval along this X axis here. This one started at 5 minutes and this one ended at 10 minutes. So that's what we just wrote, from 5 minutes to 10 minutes. That's your domain. All right, real quick, because we do want to do one thing. Notice how this one is closed up here, how we use the equal sign. That means for this 5, we don't really want the equal sign there. We only want the equal to in one or the other. So since we use the equal sign in the first one, we're going to get rid of the equal sign for that second one. All right. All right. Again, I'm going to stay on this just because this is what people tend to have the hardest time with, believe it or not. Go to the third one now. Tell me what we think the domain is for the third one. So all that means is the time. Find your third sub function up here. So this is that blue one. And indicate time-wise, when did we start with the blue function? When did we end with that blue function? Again, domain are your X's. It's our minutes in this case. All right, Omar, where did this blue one start? At what time? And when did it end? Okay, so we all know that. It starts at 10 minutes, it ends at 15 minutes. So now it's just a matter of writing it correctly. So how'd you write that, Omar? Inequality-wise? It's either greater than or less than. Which one did you do this way? All right, less than. So 10 is less than. Okay, less than or because we want to say less than. I think you probably have it right, but this is our less than sign, less than or equal to 15. So the blue one went from 10 minutes to 15 minutes. All right, follow that. All right, then that's finally when we got our third friend. Then we went to school. So real quick again, do the domain for that fourth sub function. Let's see if we've got that down pat. So now what time interval did that fourth one start and end at? So again, that is now this fourth yellow one here to here. All right. So in terms of the question, hopefully this is nice. In terms of writing it, that's the tricky part. All right. So Jada, what time do we start on this interval here? Good. 15 minutes. And we stop after how many minutes? Okay, so it's 15 to 20 minutes. That's when we do the yellow one. So that's just what we want to write in this domain. So same process. We have to start this with our 15. We want to end it at 20. And then we want our x in the middle. Basically, all the times in between 15 and 20. That's what we're writing when we do this, between 15 and 20 minutes. So we have to say less than or equal to the 20 minutes. And then we have to still, the 15 has to be in between that. So our x is on the greater than side. So this x is on the greater than side of 15. It's on the less than side of our 20. So this is how we would write those four domains. Okay, does that kind of make sense? This is what people tend to mess up the most when we actually now do these. All right. All right, then. From there, we're going to write our equations. This hopefully is what we're fairly good at. So now go to the second subfunction. So go between 5 minutes and 10 minutes. So find the line that is in between 5 minutes and 10 minutes. We want to write the equation of that line. All right, so if I scroll down, 5 to 10 minutes is this, remember, horizontal line. So we just reviewed this on the previous page. If this is a horizontal line, let me scroll on back down. Whenever I have a horizontal line, my equation will always be simply y equals some number. So look at your graph. No matter where I put a dot, what is the y coordinate at every single one of those dots? All right. And Armando, what is the y coordinate at every single one of those dots? 5. So the equation of that line is simply, so if I wrote the line, I would say y equals 5. That's this equation right here for this horizontal line. So when I go to my function, all I have to put here is a 5 because I'm putting the y out in front of it. So this is now y equals 5. All right. All right, next one. Go to 10 minutes and 15 minutes. So between 10 and 15, find that line that goes between 10 and 15. We now want to write the equation of that line. All right, so go to that time interval. So this is the long blue one on mine, a little smaller. Again, you have two tools at your disposal. You have slope-intercept form, and you have point-slope form. You have to decide which one we can use. The blue line, do we see where this blue line crosses the y-axis at? No, because we stop right here. So really, slope-intercept form for this, not really an option. So we really want to rely on this point-slope form. So find the slope of that line. So do that first. Get your slope. All right, Joel, what did you get for the slope of that line?
2.
Good. Up 2, and then right 1. Up 2, right 1, up 2, right 1, up 2, right 1. So he said the slope is 2. So for the slope spot, I'm putting in a 2. All right, then right now, I don't care what point you pick. We have a whole bunch of points that we can use to pick. We really have 1, 2, 3, 4, 5, 6 different points that you can use right now. So Jake, what point do you want to use? 1, 2, 3, 4, 5, or 6?
4.
All right. So if I pick point number 1 right here, that means I'm going to use 10, 5. So the x coordinate of that point is a 10. The y coordinate of that point is going to be a 5. This is the equation of that line. All right. So take that, put it underneath that third subfunction, and that would be 2, and then it was x minus a 10 plus a 5. All right. All right. Last but not least, go to 15, 20 minutes, write the equation of that line. See where we're at here. do this, it's either point slope form or slope intercept form. In this line here, we don't know where the process is y-axis at. Because of that, you probably want to do this point slope form. First thing you have to do is find the slope of this line. Find the slope. Okay, let's see what we got here. It's this line here. Again, slope intercept form doesn't do us a lot of good because if I ask you what the y-intercept of that line is, you're not going to be able to tell me. Okay, so while that's a nice thing to have, it just doesn't really work for this one. So our point slope form is the one that we would want to go with. So that definitely means we need our slope first. All right, so if I count this slope from this point to this point, I'm going down one, right one. I go down one, right one again. I just do that over and over and over again. So down one, right one means our slope should have been a -1. All right. Then you have all these points to pick. Doesn't matter which. I'm going to do kind of what Jake did here in a minute ago. This is the point that we have labeled. I'm just going to use that one. I'm looking around, the people who are doing it, that's what everybody was picking anyway. So then the x coordinate of that point is 15. The y coordinate of that is 15. Then this is the equation of that fourth subfunction. So we then go down -1, x minus 15, and then plus our 15. That's what we're going to put right here. So the -1, and then x minus 15, and then plus our 15. That's that fourth line. Okay. All right. What we just wrote. So to kind of wrap up what we just did there, what you see in those words there, where you see the word piecewise function, that's what we just did. All right. There were 4 different pieces to that function. So what we just did is we defined a piecewise function. That's what those are called when we have more than one. In this case, we had 4 different little subfunctions. All right. Each piece talks about the different domains in which that graph is defined. Okay. All right. So now, real quick with these questions, if I ask you to find f of 12, see if you remember this. Find f of 12 for me. Because this we've done a little bit. You would have done this a ton last year. So find f of 12. What does that mean? How do we find it? So on and so forth. Yeah, that's a good question. Yeah, probably. Yeah, give her that. You know what? No, I'm going to do this in class. All right, so there's 2 ways to find f of 12. One, just look at your graph. If you remember, f of 12 means, let me clean up my graph a little bit. Got a lot going on now. Is I am going to go to 12 minutes. So here is 10, and then 11 and 12. So here is 12 minutes. And all that means I'm going to go up from 12, and I'm going to find the y value of the graph at 12. So after 12 minutes, find that y value. Notice how it is a 9. 12 comma 9 is on that graph. That means f of 12 is equal to 9. Then I promise I'm certainly going to ask you this question in terms of the context of this. It says use the story you created to explain what this means. Well, what that means then is after 12 minutes, so this is our time, after 12 minutes, we were 9 blocks away from home. That's what that means in the context of that question. All right. After 12 minutes, we're 9 blocks away from home. All right. The other way, and this is what number 5 is asking, which subfunction? So now look at these 3 here. or these four. Look at these four subfunctions. If I wanted f of 12 means after 12 minutes. So look at your domain. So look at 0 to 5, 5 to 12, 10 to 15, 15 to 20. Where does 12 fit? The first one, the second one, the third one, or the fourth one? Caden. The third one. So what we could do is just take this function, plug a 12 into it. All right. So again, I'm going to do this right now. You don't necessarily want to erase yours, but I just want you to see what we could have. Actually, let's rewrite this below. So 2 times x minus 10, and then plus that 5. All right. So we would use this f of x equal that 2, x minus 10 plus a 5. That's the function we would use. Watch what happens now when you plug in the 12. So if I plug in a 12 right here, let's evaluate this. So 12 minus 10 is a 2. 2 times 2 is a 4. And then plus 5. Notice how that would also give you the same y value of 9 that you got on that line. All right, so you can do it algebraically with the equation, or you can use your graph one way or the other. Okay. All right. Yeah, we'll stop there. I'm going to have you work on this in class tomorrow because this usually doesn't go particularly well the first time around. So the homework is going to be something I'll give you tomorrow. You can kind of work on it. We can help you. You can work with somebody. You can talk a little bit your way through this if we have any questions. So no homework in. I won't give you homework on the first day back. Yes, sir.
I'm not going to be here tomorrow, so could I go?
There you go, sir.
Also, do you know where the PE